Okay, good afternoon, everybody. Welcome to this online Hot Politics Lab. We're an interdisciplinary group interested in the role of emotions, personality, other psychological processes, both in understanding political behavior of citizens and elites. Today we have two PhD students that are affiliated with the lab. Presenting, and they present work in progress, so please treat it like that as well, and we're very curious to hear your questions and comments for them. As always, you can ask these questions via the comments box, and then Gijs will read them out. We'll start today with the presentation of Maaike Homan's work in progress on facial mimicry. And Maaike is a PhD student at the Department of Political Science and has in the last weeks published her first article on physiological responses to both in and out party politicians and their moral transgression. So check out that work. Maaike, the floor is yours, and we're excited to have you.
Yes, thank you, Bart. I will first share my screen. Let me see. Does it work? Okay, perfect. Yeah, thanks, Bert. Yeah, I'm going to present some preliminary results. We just started data collection in the week of, Corona. So I collected 20 participants' responses, and then we had to stop data collection. So this is really preliminary results, but just to give you sort of an idea what the project is and where it might be heading. Yeah, so I'm studying about facing emotional politicians. So I'm looking at how people respond to the emotional expressions of politicians. So a lot of work always looks at what politicians are arguing, what they're saying, but not that much on their nonverbal expressions. And well, in psychology, there's a lot of evidence that it actually has a lot of effect on people, how people express themselves non-verbally in their facial expressions. So that's why I'm looking, yeah, what effect it has of politicians being very emotional, how it affects voters. And I base that basically on two frameworks. So you have this classical framework as called emotional contagion theory. And it says that when we see someone expressing an emotion, that we mimic this, and that it gives a signal to our body that we yeah, have to feel the same way. So it's sort of a loop when we see someone, for example, smiling, that we end up smiling ourselves and also feel happy. And this process is known to elicit emotions, but also increased liking and increased perspective taking and empathy. And so therefore it would be interesting to see whether this also happens with politicians. So do we also mimic politicians? Do we feel empathy for politicians? Or maybe not. And I also want to see whether there's a difference between in-party politicians and out-party politicians, since there's another theoretical framework from Agneta Fischer and colleagues from the emotional mimicry in social context model, which actually says that this process is not that automatic. It actually depends more on the context. So if the person that is expressing an emotion is someone you bond with or you have affiliation with that person, you're more likely to mimic this because yeah, this is more like an empathy process. But when it's someone from an out group, you're less likely to mimic that person and feel this empathy for that person. So that's basically the question in this project. Do we mimic politicians? And is there a difference between in-party politicians and out-party politicians? And well, previous work in political science has looked at the effects of politicians' emotional expressions on voters, but there's not that much conclusive evidence yet. So yeah, the findings are quite inconsistent, and some say that when you support someone, it leads to more mimicry of happiness displays, whereas others say it's more the mimicry of anger displays that we mimic from in-party politicians. So what we do is want to go beyond this previous work by having a bigger sample size, using the politicians from the 13 political parties here in the Netherlands, and use more systematic stimuli. So we really want to, for this study, have a very clean and consistent stimuli, and then later we can build out this and see if there's more context that can influence this mimicry process. So to create these stimuli, we had different methods. So we created 3 conditions: neutral, happy, and angry. And the good thing is that for these politicians on a government website, you have all the portrait pictures of the politicians, which are all the same ways, same format, white background. So we use those as neutral, as a base. And then we try to manipulate these pictures. So there's a lot of different techniques that can be used now to manipulate visual information. And so also lots of different apps with filters. And so there's this one app that can really realistically change an expression from neutral or from whatever expression to a happy, a smiling expression. So that's one method we used. And then there's this other method, which is more used with the SpaceGen and Psychomorph, which are programs really produced by researchers. And they, with those programs, you can sort of create a model, a base model, in which you can manipulate action units. And action units are these muscles in the face, and every different muscle that can be activated or deactivated. If you combine different muscles together, those can resemble a certain emotional expression. So we used that approach to create different forms, also mostly of the anger display, because there are not that many of those fake apps that can be used for the anger displays. So we have different versions, and we pre-tested this to make sure that they're perceived authentic. And we had very sufficient ratings of that, and whether people recognize the right emotion and whether the valence, whether it was perceived negative or positive. And overall, the results were very sufficient. Only for the anger, it's hard, a little bit more hard to find people who had really specifically all recognized anger, because anger can be expressed in many different ways. So there the scores were a little bit lower, but we will control for that in our study. At least everyone rated them as negative. So that's at least good for our study to see this negative positive emotional effect. Okay, and then the method. So we just displayed these emotional displays, these pictures, for 8 seconds. And before that, we had a fixation screen. And after that, we asked them just how that made them feel seeing this display. So we have self-report here below, and we have facial EMG. So these are these electrodes on the face you can see on the picture. We measured corrugator activity, so which is an indicator for frowning. And we used zygomaticus activity, which is used for smiling activity. And we used some moderators, but I won't go into depth to that because we don't have enough power to say anything conclusive for now. And what we also did is we added 2 more measures just to give a sort of indication of how our measurement is working. So it's basically sort of validation of our physiological measurements. So first of all, we used 2 negative pictures and 2 positive pictures from the International Affective Picture System. And we just want to see if indeed these negative pictures who've been rated in other research as very negative, we indeed find also more corrugator activity in response to those pictures. And the same for the positive, but then with zygomaticus activity. And then we also added pictures from the Amsterdam Dynamic Facial Expression set. And we wanted to do it to see, to have like politicians and non-politicians and see whether this mimicry process is dependent on whether it's politicians or not. And from this set, it's just models that are, just normal, regular people, basically. And we included a male model and a female model from this data set, and a neutral, happy, and angry condition. And these were shown the same way as the emotional displays of the politicians. And so what I already said in the beginning, we just started collecting data in the week that Corona started. So we just had 20 participants and then we had to stop, unfortunately. But we are planning to start data collection soon. So probably next week we can start again, and we want to collect 100 participants as we pre-registered. And so for now, I can say a little bit, I can give some tentative results. Because we have 6 conditions for in-party and out-party politicians, and then 3 emotion conditions. So if you stack them together, you have enough power to say a little bit. But of course, I like to present again when I have all the 100 participants collected, and then hopefully can give some more conclusive evidence and answers. So how I process the data. So for Mimicry, so for all physiological measurements, it's good to filter the data to make sure that there are not a lot of outliers and a lot of noise. Then we standardized all the physiological data. And then what we did is made a facial activity index. So there's this group of researchers who do a lot of work in mimicry literature, and they suggest to combine the zygomaticus activity and the corrugator activity, in the sense that when you mimic an expression, this is a facial pattern. So there's a pattern of muscle movement in which when you smile, you automatically have also lowered, you're not frowning. And the other way around, when you're frowning, you're not smiling. So in that way, you can make a sort of an index, and that can give you an indication of mimicry, or at least a positive versus negative response in the face. So that's what we used. So I'm now going to show some results. So for the physiological measurements, we do not find that much significant results, but we can give a sort of an indication of direction. But hopefully when we collect more data, we can give more conclusive answers. But so on the left, you see the responses to the IEPS pictures. So these are pictures, 2 very negative ones. It's someone being threatened with a knife and a baby with a tumor. And on the other hand, there's a very happy baby and a picture of a family. And for this is not per se mimicry. We just want to see whether our measurements are working the way we want them to. And here you indeed see the same, the direction that we would expect. For the corrugator, you indeed see when the pictures are negative, there's when the pictures are positive, there's less corrugator activity, and when the pictures are positive, you see more zygomaticus activity. So that's at least in the direction what we would expect. And for the mimicry pictures from the ATVES data set, we see we don't see any significant results. It's hard to say anything about this. We do see a gender component that might be interesting to look at a little bit more. So we have a male model and a female model. So it might be that there are some differences there, but yeah, we have to see when we have all the results, all the data, whether there's actually some significant differences here. And now the main analysis. So it's quite a large figure, but if you look on the right, you see all the different types of displays. And this is all against the in-party neutral condition. And above, you see in the columns, you see the outcome measures. So for the facial index that we created, we again don't see that much significant results. There might be some directions that we could look at, but for now it's hard to say anything conclusive about this. But when we look at the self-reports, we can see some directions here and significant results as well. So for example, if you look at the in-party angry condition compared to the in-party neutral condition, we indeed see that there's more reported anger compared to neutral, more reported anxiety, and less happiness. So this does indicate a sort of pattern of mimicry. And what we find in general in this result so far is that anxiety and anger self-report correlates very highly with each other. And yeah, we found it also in our other study with physiological responses towards the in-party and out-party politicians, that it really correlates very highly. So it could be more sort of a general negative effect. And yeah, so if I go on, if you look at the in-party happy displays, then you see indeed lower anger, well, no effect of anxiety, a little bit more happiness compared to the neutral condition, although this is not significant. There might be some direction here. Then if you go to the 3 out-party displays, you see a lot of anger and anxiety going on. So a lot of negativity towards the out-party conditions. And yeah, basically, despite all the emotion conditions, people are very negative about just seeing an out-party politician. And yeah, they report way lower happiness compared to in-party politicians. And if you look a little bit more closely, because now we have in-party neutral condition as a reference, but if you really want to look at the mimicry for the out-party politicians, you really have to look into the out-party neutral versus the emotional displays. And there you could see a little bit of a difference. So compared to neutral, in the angry display, there's a little bit more reported anger self-reported, and a little bit less happiness, and the other way around for the happy condition. Although these effects are quite small, so it's hard to say if this is actually mimicry. So what it looks like now is that for the in-party, there is, at least in the angry condition, there's clearly some mimicry going on. And for the out-party, for the happiness condition, for the in-party, that's less clear, but it is in the right direction. And in general, for the out-party, people are very negative, just seeing out-party politician. So that's the biggest takeaway from this result so far, I think. So some indication that we mimic the emotional displays of in-party politicians, maybe less of out-party politicians, although it's hard to say. And I think that these results will be really interesting to see whether people are actually open to empathize with out-party politicians. Since this mimicry process is a process of empathy, it will be interesting to see if people can still be open towards people from a different political spectrum, especially in a debate with effective polarization. And yeah, I think it would be interesting to see what the physiological responses will do, especially the validation measures that we included, to see whether there's a difference between politicians, mimicking politicians, and just the regular people that we included expressing emotions. And I think it would be is a nice way to also sort of validate your measurements, especially since physiological measurement is so sensitive. And yeah, I hope to show some more results later, probably in a couple of months, and yeah, to show whether the mimicry, how it especially goes in the physiological measurements, whether there's no response at all, or whether people mimic but then cognitively adjust, or whether it's actually aligned with the self-report. So to be continued. And thank you. And I also just wanted to take this opportunity to recruit participants. So if you know any people, Dutch participants or Dutch people who are interested in participating for €10, let me know. There's my email address, and well, also the lab website. And yeah, thanks again.
Thank you, Maaike. And it's now time for the Q&A. So we have 10 minutes for the Q&A before we go to the next paper by Christian Pipal. So you can ask questions in the Q&A box. And I already see one. From Agneta Fischer, our speaker for next week. And her question is, you only showed the face, right? And most effects with the neutral face.
Most effects with the neutral face?
That's what it says.
Yeah, yeah. So indeed, I only showed pictures, especially because in the beginning, we were really trying to create videos with really this deepfake techniques, but it turned out to be still, to be developing and not yet really available and applicable, for research. So we decided to go for pictures. Indeed, in the mimicry literature, there's a lot of evidence that that's dynamic stimuli, it leads to more mimicry, but there's also evidence of other literature that shows that also pictures could be used. And indeed, if you look at the politicians, just the neutral version, for the in-party politicians, you see that people report more happiness in general. And for out-party politicians, just neutral, you also see opposite. So not at all any happiness and a lot of anger and anxiety. So based on that, you can already see that the seeing a politician already elicits emotions. And it's interesting to see then what expressing an emotion from a politician then adds to that.
Maaike, there's a follow-up question, whether you can show the results slides again, maybe. I would like to look at that as well. Then in the meantime, I see a question from Patrick Stewart. He says, very exciting research. I'm looking forward to the results. Could you clarify for me whether these are images or video clips of politicians? But yeah, I guess you answered that question, right?
Yeah, I didn't show the stimuli because while we're still running this study in the lab, so I didn't want to share them, especially just being recorded.
Yeah, exactly. But maybe we can later on share some material over a secure.
Yeah, definitely. You can also send me an email if you're interested.
Okay. Next question is from Matthijs Roduin, and he actually made it. Maybe had access to the Zoom meeting. The question is, thanks, Maaike. This looks very promising. One question, the study is conducted at the University of Amsterdam. Does this mean that there will be a bias in terms of political preferences, and thereby in terms of which party is the in party and which one out party? If yes, how do you make sure you have enough variation in your sample?
Yeah, no, that's a very good question. Actually, I was surprised, but maybe 20 people is not enough to actually see the normal distribution. But actually, quite also some students, mostly students in the lab, that were right wing. So for voting for the VVD and had a left wing party as out party. But in general, you don't see many populist voters, at least. So yeah, there is some variation, but not that much. And there are some people coming from outside the lab, which I found that there are more variation in political preferences. But indeed, it's something we should take into account. And it would be good to maybe do later a follow-up study or a similar study, and maybe see if there's also differences in more extreme political preferences, I think.
Okay, next question from Stuart Soroka. This is cool, thanks. How do you see this work relating to viewer selection choices in media use? Do we select into a story about a politician in order to share, mimic, although the causality in this instance would be less straightforward? And then between brackets, I'm thinking about uses and gratifications work in communication mostly.
Yeah, interesting question. Yeah, definitely. Well, there's been research showing that indeed, just if you're on social media and there's a post with a picture, that already grabs more attention than without a picture. Then it's the question, what about just showing a politician, and also what about if it's a politician expressing an emotion? Well, there is literature showing that just emotions in general or facial expressions are very attention grabbing. So it does maybe grab more attention than other visuals. But about the causality, what will happen, whether people mimic it, it could be that when people see a politician expressing an emotion, that it maybe also elicits some emotion in them and making them then wanting to click or read up on the article or the post. but yeah, this is just speculation. I'm not sure. Would be interesting to investigate. Yeah, definitely.
Next question from Patrick Stewart again. Thanks. With the happiness displays, do you differentiate between types of smiles? And do you think, do you consider attractiveness and facial characteristics? Broader faces, for example, encode anger to a greater extent just in the resting neutral state.
Yeah, that's also really interesting. So we had different versions of smiles, and the one with the created with this face app was a really big open smile with the teeth showing, and that one was in our pretest rated as like really high on positivity, and on or everyone rated that as that's smiling, that's happiness. So that's why we chose that one. So all politicians are having the same smile in the same way because it's all the same filter. So that's very consistent. Yeah, you could look more into different types of smiles, of course. And yeah, for facial characteristics, that's a really interesting great thing to research. I definitely think there might be a difference between people who look neutral already look angry, which happens with some politicians. So when we look into our pretest results, we indeed see for two politicians it was very hard to create good angry results, because I think that their faces were just naturally more open or baby-faced or something like that. So it's very interesting that maybe also the when they show anger, it's also less. Yeah, you can perceive it that much as other people who have less of a baby face. So I think, yeah, looking into facial characteristics and interaction with emotions is also super interesting to research after this.
And we will keep. Will we keep it a secret whose faces were able to be seen as angry?
It was it was Usher from the Social Democrats, and Van der Staaij from Conservative Party, religious party, and their faces are. I think it would be interesting to do a study and to rate them on facial attractiveness and characteristics. But if you already look at them, indeed, you could say that they are a bit more baby face, and their neutral is not that neutral. It's more, something like that.
I have one more question, and I think we will have time for one more question. So I want to encourage people with a burning desire for asking a question to write that into the Q&A box soon. But first, the question we already have from Nico Berg. Hi, Maaike. Thank you for this great presentation, despite the changed infrastructure. If I read the results correctly, you mainly presented valence measures. Any results for arousal? Also, if the effects would hold for the party effect being larger than the effect of the politician's emotional states, what implications do you see for political communication more generally?
Yeah, wow, great question. So about the arousal, we did collect skin conductance. I didn't include it for now. In our previous study experiment, when we looked more at how people respond to more transgressions of politicians, we did have a skin conductance measure, and it didn't do that much, if I remember correctly. So for now, I didn't really look at it. I don't want to make it too complicated also for this presentation, but when I have all the data, I will indeed look at the arousal, and I want to see whether it indeed follows neutral versus emotion condition. And so that would be very interesting to look at. And the second question, what was it again? Sorry, I forgot.
If the effects would hold for the party effect.
Oh yeah.
Being so the fact that there's mostly in party out party, not so much the politician's emotional state.
Yeah. So you see such a big effect of out party and in party that indeed it's a question whether these emotions then do they then actually achieve something that should have an effect? Well, yeah, for the in party that might be the case, but for the out party it might be that people are so already biased and so negative that out party politician smiling doesn't really have an effect on them. Yeah, so that would be interesting to look at, definitely.
Okay, there's one more question, but it's more a suggestion. Again, from Agneta Fischer, she writes, there are studies on the facial features in relation to gender and emotions by Ursula Hess. So you might want to check that. In addition, there's work by Alexander Todorov about this as well.
Yeah.
And you've just published a review on Alexander Todorov's book. So
yeah. Yeah, so I definitely am familiar with the work, yeah. And also the paper by Ursula Hess. Yeah, and well, we're going to teach next month, and hopefully some students want to, have to do research projects, so maybe they want to also research this. But it's definitely something interesting to look at, the facial attractiveness and features. So, yeah.
Okay, great, thanks. Okay, thank you, Maaike, and good luck with the, also on behalf of your co-authors, good luck with the rest of the data collection. I really hope next week we're in the lab with
yes, yeah, thank you.
Students. Let's switch to the next presentation. Christian Pipal, also a PhD student at the Hot Politics Lab, working at the Department of Political Science in the at the University of Amsterdam, under the supervision of me and Bert Bakker and Maaike van der Velde. Christian, I give you the floor.
All right, thank you. So after hosting these events for a couple of weeks now, I'm happy that I can also present my work here now, switching the sides. So what I want to show you in this presentation is an improved way how we can measure emotions and sentiment in political texts by combining dictionaries with a semi-supervised model to improve dictionaries. So I want to give a brief overview on how we measure sentiment, what we're going to do. And then I want to show you a couple of examples that showcase that our method indeed performs better than other methods. Just very quickly, there are different ways how you can measure sentiment. Sentiment means how positive or negative something is, a political text, a document in this case. You can code them manually, which is very expensive. You can use the crowd, less expensive, but still quite difficult to do. You can use dictionaries. This is what I'm going to be focusing on. Dictionaries are developed word lists that have been developed and validated that assign positivity or negativity to different words, and then you look for these words in the text, and depending how many matches you have in the categories, you judge the text on being positive or negative. And you can use supervised learning, which is again involves some kind of coding to train a model. So I'm focusing on dictionaries here because they are the most used tool to measure sentiment in text, and generally speaking, they perform pretty well. But the problem with dictionaries is that they're completely context independent. So what do I mean by that is that if you have a word that's placed in a category, for instance, into a negative category, no matter what context that word is used in a document, it's always considered being negative. And if you think, for instance, this mock example that I give here, when you look at the word low, it could mean different things. If it's used in a context of talking about economic growth, it indeed means something negative. But if it's used in the context of fighting climate change and you use it to describe low carbon emissions, then it's actually something positive. And that's something that dictionaries cannot pick up. And what we do is we combine it with a semi-supervised topic model from computational linguistics that allows our method, the dictionary, to actually recognize in what context the word is used in. So this has been used in computational linguistics for a while, and we adopt that and implement it and show that this indeed gives us two main benefits when we measure sentiment using dictionaries. The first benefit is that if we use this model, we can improve how you can improve the overall measurement of sentiment in a political text, in a political speech. But we can also identify topic-specific sentiment. What do I mean by that? For instance, if you have a political speech and a political speech covers multiple topics, for instance, it talks a little bit about the economy, it talks a little bit about the EU, it talks a little, the speech talks a little bit about security. If you just measure an overall sentiment of that speech, yeah, you get an impression what's the general tone of the speech probably, but you might also be interested in how positive or negative is that speaker about the topic. How positive is she about the EU? How positive is she about the economy, etc.? And what this model allows us to do is that we get exactly these topic-specific sentiments. And that's a novel thing. I'm not aware of any other method at the moment that gives you that that easily. So the two implementations of this model, one implementation is called JST, Joint Sentiment Topic Model, which assumes that sentiment comes first in a text and then topics are clustered within this sentiment, and the reversed version, which assumes a text is structured by topics first. Because of these different approaches to measuring these two things, one is better suited than the other. So JST is better suited for measuring overall speech sentiment, and the reversed version is better suited for measuring topic-specific sentiment. We implemented, implemented in R. It uses prior information from a sentiment dictionary. So we're not getting rid of dictionaries, we still use them as a prior for the model. And similar to a classic topic model, you have to choose a number of topics in advance, and I'll show you later how that influences the results. There are three ways of validation and illustration that I want to show you now that display the benefit of what you can do with that, and also that it's better than just employing a dictionary. So I show you some kind of face validity by looking at sentiment over time. I show you an example of topic sentiment word combinations, and I then show you how we, when you compare it with a coded data set that we created, how our method performs compared to standard dictionary applications. So the first thing I want to show you as a sign of face validity is the development of sentiment in parliamentarian speeches in the United Kingdom, in the House of Commons over time by political party. So what you see here is in red, you see the average sentiment in a quarter by the Labour Party, and in blue, you see the same thing for the Conservative Party, for the Tories. On the y-axis, you have that sentiment. And if you look over time, you see that they're flipping. So when there's a Labour Prime Minister, Labour MPs are more positive than Conservative MPs. And when there's a, if you look, for instance, at 2010, when David Cameron came into office and there was a Tory MP, you see that it flips and suddenly Tory MPs are more positive than Labour MPs. And this is exactly what you would expect because there are different incentives in Parliament to speak and how positive you can speak. Government MPs should promote the government and promote government policies, and opposition MPs should have to criticize that. So seeing this result is quite encouraging because it shows that what our model picks up and gives us as a result of speech sentiment is in line what we would expect. Very quickly, we see the exact same thing in Germany. When the two major parties in Germany, or at least at that time major parties, the CDU and the SPD, when they governed together in the late 2000s until like 2010, we see that they're equally positive, the sentiment is equal, and then when the other party is in office and the other isn't, that party is in office, their MPs are more positive than the other. So that's very encouraging that we see that. Indicative that our model works. The other thing that I said is that this model allows us to give us topic-specific sentiment. So you don't only get a sentiment score for an entire speech, but you also get a score for each topic that topic part of that model finds. And it's a researcher's task then with any kind of topic model to interpret these topics. And I picked up one of the topics here that I identified as being about the EU. So this is again based on all the speeches in the House of Commons over time. And I look at what's the sentiment towards the EU. When parliamentarians speak about the EU, how positive or negative are they? And what we see here is that the development over time, and it was very negative in the late 80s, became more positive till the 2000s, and then became more negative again. I don't want to interpret now too much into this here and saying like what's the reason for that, but it shows it picks up something, it picks up variation, it changes over time. When you split that curve then again by party and you look what's the difference between conservative and Labour MPs, I looked at this here just from 2005 to make it easier to see differences, but also here we see it picks up a difference. So parties are different, but it's not as clearly pronounced that it's just that it is necessarily the Prime Minister party who's more positive. But it picks up a difference, and I think that's interesting to see, that this model picks up differences. So the next way I want to illustrate how this model works is to look at the words that this model finds that are indicative of sentiment within the EU topic. So what you see here is 3 different word lists, and each of the lists is indicative of a certain sentiment in connection to a topic. So when you look at the positive category, you find words like join, cooperation, constitute, right, common, that point towards positive sentiment regarding the EU topic. When you look at the negative category, you find a lot of country names, which kind of makes sense when you look at it, that this is more that you would expect politicians that talk negatively about the EU to refer more to the nation state. I'll skip the next slide because of time. But the most interesting part then is now to see, does our model perform better than just employing a dictionary on a text? And I'm gonna explain this graph now a bit. So what did we do? So we ran our model on individual parliamentary speeches from the UK, and then we took 200 speeches and coded them. So we coded them if they are neutral, positive, or negative. It's a very rough overall, just what's the overall impression of that speech? How positive or negative is it? Is it positive or negative, or is it neutral? And then we tried to explain the variance in our automated measures with these human codings. So what you see in this graph is the amount of variance in the automated measure that is explained by the coding measure. So this is basically the R squared if you run then a linear model. And what you see here is that you have to look at that over the number of topics, because as I said, you have to set a number of topics beforehand. But of course, it's hard to determine. Everyone who uses text analysis, this topic model, it's not that clear and easy to know what's the right number of topics in the text. So we run that with a range of topics from 1 to 100 and see how we perform in terms of R squared. The flat lines are just the pure dictionary applications, because they, of course, they don't change, because they don't incorporate any kind of topic information. The dictionary, if you run it on a text, it's always the same, because there's no topic variation. There's no topics in there. And we use 2 different dictionaries. The Lexicoder dictionary as implemented in Quantida, I have to say, and a dictionary that was specifically developed for British parliamentary debates by Ludovic Raut and colleagues in 2016. And what you see here is, as expected, the dictionary that was developed for that corpus for parliamentary debates in the UK in the red flat line, that performs better in terms of R squared than the more general Lexicoder dictionary. And the main point, what I want to show you, the good thing, of course, that shows that our method works pretty well, is the more wiggly lines show you how the results from our model performs over the range of topic numbers. And we consistently outperform the pure dictionary application. So the blue line that looks a little bit like a little hill, it shows you that when you just run it with one topic, it already outperforms the pure dictionary. And as you increase the number of topics, it gets better and better, and then really significantly outperforms the dictionary application. And then as you overfit, so to say, if you have too many topics, it decreases again. But still, even when you increase if you increase the topic number quite a lot, you're still outperforming the dictionary substantially. And that's the same for the Real dictionary. That's in the red mountain, in the red hill. Although there the improvement is not as big. So what we see here is that if we want to estimate general sentiment in political speeches with that method, it does what we expected. It performs better than just running a dictionary on it. So that's very encouraging. But again, this is now just run on 200 coded speeches. So it's kind of preliminary, of course. And I go show you in a bit what we're going to do to increase that, our confidence in that. What I also did then was to look at the same thing, but look at the topic-specific sentiment. So that's a little bit a different thing we did here then is, so I took again the EU topic and then we coded how positive is a text regarding the EU. So this, of course, then you have for each topic number, you have to have you get a different model result. You have to interpret the word list. You have to interpret what is the topic that is about the EU, and then you can compare it to a dictionary measure, to just employing a dictionary. And what do I mean by that? I selected 200 texts that scored very highly on being about the EU. So that's what you would usually do if you don't use our model. If you have a text and you don't know what texts are about, but you want to get a hunch of sentiment towards a topic, you would run a topic model on it, and you would select topics that score high on your topic of interest. You take those texts, and then you employ a dictionary on these texts where you know that they're talking a lot about your topic of interest, here the EU, and you would then run the dictionary on it. So I took the 200 speeches that scored the highest on being about the EU. So this is, of course, this is now a test that's very much where we know that these texts are about the EU, and ran both the dictionary and compared it to the results that we get from using our model. And the first thing you notice, here, we outperform the dictionary.
Christian, you have like 1 minute left. So
yeah, this is my last slide.
Okay.
We outperform the dictionary. What you can also see is that only after topic number 20, we have a score for our method. That's simply because if you have less than 20 topics, there was no topic identified by the topic model that was just clearly about the EU. Yeah, we perform better here as well. What are the conclusions? Including topic information is good. It increases the confidence you get into your sentiment measure, but also you can use it very well to get topic-specific sentiment. And I think this is something pretty unique and cool. The next steps is that we want to expand this validation. We look at 3 different topics. We take 400 speeches per topics, get them coded by different coders, and then get a big data set so we can show that our model works in different languages across different topics. And yeah, I will use that as the first paper for my PhD, and the rest of my PhD is then using this method for researching the use of emotions by politicians. Okay. Thank you.
Great, thanks a lot, Christian. And it's time for questions again. So you can write your questions in the Q&A box. In the absence of a question currently, let me ask you a question of a few slides back where you find that this, no, stop. The one with where you compared for, yes. I mean, this on the one hand looks very promising, but what is a little bit? Can you just explain to us how the K is one topic one option can outperform the dictionary?
That's very simple. So K equals 1 would mean it's basically just applying the dictionary on it. So there's no topic information in there. So you would get one topic, you would get 3 sentiment categories for the topic. So that's basically just a general, positive, negative, and neutral category. But it outperforms just a dictionary because it takes the dictionary as a prior information and then looks what words appear in these contexts and it ditches words that seemingly appear in multiple contexts and should be placed in different categories. So ultimately what it does is it gets rid of all the words that appear in different that would appear in different different sentiment categories. So it kind of it takes a general dictionary and ties it a little bit closer to your domain of interest. So that would be my explanation for that.
Yeah. Okay. Bert has a question.
It kind of relates to this. Thanks for your presentation, Christian. But can you say a little bit about the effects here? Because you had a lot of, long explanation for a 0.01 increase in R square, right? And as we move on, it's, in the best scenarios, there's like a couple of there's some increase in R square. But what does this mean? What do we gain with this? So and why should we care?
Well, where do you see a 0.1 increase?
Well, at the method is 1. Like the lines are pretty close. It's okay. It's a little bigger, but still. Can you give me a little bit of a explanation of what does this mean? Like a 5 to 10 increase in R square. What do we gain with that?
Well, it increases your confidence in what you measure is indeed what you want to measure, right?
So would there be ways to show me that if I what other conclusions do I draw the wrong conclusions if I use the old methods, or do I get?
I don't show that here in this presentation here, but what we also did is we converted our automated measure, the continuous automated measure of sentiment, into 3 different categories: positive, negative, and neutral. These 3 different groups, and then we looked at how many speeches do we misclassify. That is a classic machine learning validation exercise. And I don't have it in this presentation here, but we reduced the error rates of how many speeches we misclassify substantially.
Yeah.
Okay.
So we not only we increase our classification accuracy, not overall, but what I think is pretty striking is that we increase both our correct detection of positive. So we increase the correct detection of sentiment categories, but we also miss fewer correct categories, if that makes sense now, how the way I explained it.
Okay, next question is from Matthijs Rodijn. Thanks, Christian. You've shown some large peaks in the UK graphs. Could you tell us more about this? Are there obvious events explaining them?
Which UK graphs? I guess it's this graph or the EU graph.
I think the first one in the presentation.
Yeah. I don't know. I think, of course, I mean that I'm pretty sure that those different peaks depend on the context a lot, and I'm now at this point not really aware of that context, how that differs between those different peaks. And I wouldn't want to like interpret now, make up a story that explains that.
Mm-hmm. Yeah. But in this graph, but also in earlier work, you do see a trend line towards more positivity, which is very striking and against commonly held opinions on how parliamentary rhetoric is developing. Okay, I shut up. There are a lot of questions now. Thanks, Christian from Nico Berg. Super interesting for anyone interested in sentiment analysis. What future applications do you have in mind?
I mean there are two takeaways from using this model. First is that it just improves it increases the confidence in a sentiment measure, and I think that's useful per se. But the even more useful thing is that we can look now at topic-specific sentiment. So if we have news articles and we don't know what they are about, or political speech and we don't know what they're about, but we're interested in something that is targeted towards a certain issue or a certain topic, we can now easily do that. For instance, one example would be if you want to look at conflict in parliament regarding a certain policy issue. In some parliaments, for some countries, for some time periods, you know what debates were about. But most of the time you don't have that, and it's pretty hard then to figure out a way to look at. For instance, if you want to know, if you want to study the debates about the European Union in the UK, and you want to see how policy stances of the parties changed over time, or if they got closer together or deviated more from each other. Sentiment analysis is a way you can do that. That's a new way people start doing that to measure conflict in parliament, policy conflict. But with our method, you can study policy conflict specific for a policy area, for instance. Another example that I'm going to use in my other papers for my dissertation is looking at sentiment for different topics and try to explain that if there are different strategic reasons why politicians change their positivity, their sentiment towards the topic, but not in other topics. Yeah.
We're almost out of time, but there's room for one more question if anyone has it. Oh, yeah. So there's a question coming from Stuart Soroka. Maybe I'll take a minute first to announce the next few speakers until we wait for Stuart's question. Next week, we'll have Agneta Fischer, the Dean of our faculty, to present, and a professor of emotion psychology to talk about her work on fear and populism. And then the week after, we'll have Ryan Boyd from University of Lancaster to talk about the language and psychological characteristics of it. Then the week after that, we have Chris Federico, who now I'm looking at Bert because I forgot the topic. Maybe Bert, you can name the topic.
Yes, Chris will talk about collective narcissism and nationalism. A really interesting work in light of the developments in the United States and other countries.
And then the week after that, that's I think if I'm correct, 26th of June, we'll have our last meeting of this academic year with again a PhD meeting like today with Isabella Rebasso from University of Amsterdam and Tobias Rohrbach from the University of Fribourg. Now, Stuart has not asked a question, but more like written down an essay. So don't go home yet. All of you are home already. So let me read this out. This is terrific stuff. Thank you, Stuart. A domain-specific method should always beat a general method. So the marginal increase you see here with your method is really important. As is the improvement from the general LSD to the UK dictionary. That should happen. Otherwise, there's a huge flaw in the domain-specific dictionary. I have 2 points, not really questions, but maybe this is helpful. 1, I like the improvement in fit that happens in a single domain a lot of content analytical work isn't using parliamentary speech. It's using discussion of topics we don't know about. Often we know we're looking at a debate about a given policy or media coverage of the environment. So finding topics is of a limited advantage there, but improving results within a single domain is really interesting. Second, no reasonable sentiment dictionary includes the word low on its own. I ditched that example and I find another few real-world examples of where your method beats the standard approach drawn from a human-coded corpus.
Thank you, Stuart, for that. That's really helpful. Around the first thing, I think the improvement of fit as well. That's pretty important. True. In a lot of studies, in a lot of research questions, and a lot of text you use for that, you know what topic is being discussed. But still, again, but then if you just employ a dictionary on it, of course, it picks up sentiment words that are not about this topic. So, for instance, political speeches. Even if a speech criticizes the budget, you still have probably 3-4 sentences in the beginning where they thank the previous speaker, thank their own minister, blah blah blah, and that would then interfere with your measurement of that sentiment regarding the topic. So yeah, and regarding the second point, you are absolutely right. That would be a good thing to think about. Yeah.
I think that was my only contribution to this presentation. So I'm sorry, Christian.
What?
I think I came up with that example.
I'm not saying anything.
All right. Blame avoidance or blame sharing. Okay, that's it for today. Beck, you want to do the outro? I already did the. Okay. I hope to see everyone next week between 3 and 4 for Agneta Fischer's presentation. I'm really looking forward to it. Thank you for your questions and participation today, and see you next week.